This question came from 11-year-old John. He says, what would happen if Mars suddenly became a habitable planet? Let's explain it like this. Even if it didn't happen suddenly, what would need to happen for Mars to become habitable? Then let's explain it right away. Scientists have been thinking about making Mars habitable for many years, and the answer is both incredibly exciting and a little terrifying in terms of scale. Turning Mars into a place where humans could walk outside comfortably without a spacesuit is called terraforming, and it is the most ambitious engineering project humans have ever imagined. The first problem is the atmosphere, because right now Mars almost has no atmosphere. Surface pressure is less than 1% of Earth's. The air is 95% carbon dioxide, and there is no protection against radiation coming from the sun. First, we need to heat the planet. The most talked about method is releasing huge amounts of greenhouse gases. This could be done either by factories on the surface producing fluorine-based gases, or by redirecting ammonia-rich asteroids and intentionally crashing them into Mars. Yes, you heard that right. Intentionally hitting a planet with an asteroid has been proposed as a scientific idea. Increasing Mars's temperature by just 4 to 5 degrees Celsius could start a chain reaction, because Mars's polar ice caps and soil contain enormous amounts of frozen CO2. As the planet warms, this CO2 would sublimate directly into the atmosphere. That would thicken the atmosphere, trap more heat, release more CO2, and the process would repeat. This feedback loop is actually the same process we try to avoid on Earth, but on Mars, we would deliberately try to start it as fast as possible. Depending on the method used and how aggressive the process is, reaching habitable atmospheric pressure could take between 100 and 1,000 years. Even after all this, Mars still wouldn't have oxygen, because CO2 is not oxygen. The next stage would be biological. Mars would be seeded with genetically engineered cyanobacteria and algae designed to survive harsh conditions. Through photosynthesis, they would slowly convert CO2 into oxygen. This process already happened on Earth about 2.4 billion years ago, during what we call the Great Oxidation Event. On Earth, this process took hundreds of millions of years. On a terraformed Mars, with engineered organisms and the right conditions, it is estimated to take about 100,000 years. And there is also the magnetic field problem, which is probably the hardest one. Earth has a strong magnetic field generated by its rotating molten iron core. This field protects us from the solar wind and prevents our atmosphere from being blown away into space. Mars lost its magnetic field about 4 billion years ago when its core cooled and solidified. Without it, any atmosphere we create would slowly be eroded by the sun over millions of years. One proposed solution is placing a giant artificial magnetic shield at the Mars L1 Lagrange point, a location in space where an object can remain in a stable position between Mars and the sun. In 2017, NASA scientists published a paper suggesting that this could theoretically be possible and that such a shield could protect Mars's atmosphere indefinitely. Finally, there is the gravity problem, and this is something we simply cannot change. Mars's gravity is 38% of Earth's, and that is permanent. Because to change a planet's gravity, you would need to change its mass, and there is no realistic way to do that. So even on a terraformed Mars, with breathable air and oceans, every human born there would grow up in lower gravity. They would likely develop weaker bones, different cardiovascular systems, and probably taller bodies. After many generations, Martians would become biologically different from humans on Earth. And this difference would exist purely because of physics, so we wouldn't just be building a new planet. We would also be creating a new type of human. So how long would all of this take? According to scientific estimates, a habitable Mars where you could walk outside with just an oxygen mask might be possible in about 200 to 300 years. But a fully Earth-like Mars, where you could breathe the air freely outside and where stable ecosystems exist, would require tens of thousands of years. Which means this: the people who start this project will never see the result. Their children won't see it either. Even people hundreds of generations later might not see it. It would be the largest project in human history. We would start it, but the ones who finish it might not even consider themselves human in the way we understand today. This might be the most depressing thing you heard this week, or the most inspiring. And honestly, it's probably both.